thank you for being here. So I'm the last session before drinking, so I'll be fast and efficient. I'll do my best, at least. Quickly to introduce myself, I'm full stack developer at Sagi, which is a big data platform available as a service. I'm also the co-leader in France of DevOps for Kids, an initiative to teach children coding. And you can find me on Twitter with this handle. And I'm very, very, very happy to be there this year again, because first of all, it's a great event, and then I learned last year on this precise stage a very important lesson. Never rely on Wi-Fi to make a drone fly. Yes, it has happened twice. So I sold them. I have no drone this year, sorry. So, real-time. As you have probably noticed, real-time is the new norm. It's present in every application you're using in your day-to-day life, whereas it's personal applications or professional one. So it's what users expect from us now. And the thing is that real-time is not only for data, it's also for event. You probably want your users to be notified when something new has happened. You want them to be able to react to events. But events are a little bit different from data. First of all, they are completely unpredictable. You never know when your fancy new IoT sensor will detect something. You never know when a new video will be posted on YouTube. So they are completely unpredictable, and they have different usages. They can be just consumed as they arrive, a new video posted on YouTube, a new blog post published on WordPress, but they can also be the beginning of a new workflow. So it makes them completely different from data, and that's the reason why we're going to see which is the best solution to deal with them in real time. So first of all, let's talk about polling. So that's polling in the perfect and wonderful world of theory, where I would love to live, because actually there is unicorns and everything goes fine, you know, there is no war and all that kind of things. So polling is making a request, waiting for the answer, making the same request again, waiting for the answer, and so on and so forth. Unfortunately, we are living in the cruel world of practice, and in the cruel world of practice, polling looks like that. So you will probably make a lot of useless calls before retrieving something new, and people at Zapier have noticed that more than 98% of polls were just wasted. So please stop with polling madness. It's not a solution, and we're not going to talk about it anymore. So let's have a look at proper solutions. And let's start with WebHooks. WebHooks, first of all, you can find them under several names, including user-defined HTTP callback or user-post-defined HTTP callback. It's a concept, a method. There is no specifications, so don't search for them. They got this really nice website where you can find a lot of documentation, and there is also a Google group which is quite active. And they got a logo. And that's all that we can say about WebHooks at the moment. From this precise point, it's completely yellow. Everybody is doing it the way they want. So, how does it look like in theory? First of all, as a consumer, you have to register your callback URL to the API provider. So you're going to make a post request to the API provider, giving him a callback URL, and say, okay, so I would like to subscribe to your events, and that's the callback URL to use to send me events. And the API provider is going to answer with a 201, typically, saying, okay, subscription created. Then it's going to wait it for updates, and each time a new event occurs, it's going to make a post request on your callback URL with every information about the event in the payload. So it looks pretty simple, but actually there is a little bit of work to do before making it work. So first of all, as a consumer, you got to define a callback URL. And this callback URL has to be accessible from outside. So it means no localhost, not behind the proxy, not behind the firewall. As an API provider, first of all, you get to create a subscription endpoint. And actually, well, ideally, let's say, because it's YOLO, ideally, you will need two different resources. The first one, the /webbook, will be used to first retrieve every webhooks you propose with the get method, and to create subscription with the post method. The /webbook/id will be used with the get method to basically retrieve the content of the last event. The put will be used to update the subscription, because perhaps the user wants to update its callback URL, for example. And the delete method will be used to close the subscription. And then comes the tricky part for the API provider, because then you have to implement your webhook queue. A few solutions exist. The inline HTTP request is not really a solution. I would not recommend that. Basically, you are going to, each time you get a new event to send, look at every subscription you have and programmatically send the request. So you will have to deal with retry and failure and everything that can go wrong. It will probably delay your answer. It's not a solution. It can, I mean, perhaps you can use it for a proof of concept, for example, but that's all. The SQL-based queue, it's not my favorite one, but it could be nice if you can't afford to add another piece of technology into your stack, which is sometimes the case. So in this case, you're going to simply record every subscription you have to send, every notification, you have to send each time a new event occurred, and then you will need a dedicated task to roll over it and to loop over it, and to send notifications. So it could work, but it will not be very scalable. AMQP broker, to me, is the best solution if you can afford, or if you already have an AMQP broker in your stack, like, for example, RabbitMQ or Redis or whatever. So in this case, you will still have another task which is going to loop over subscriptions and send messages, but your SQL-based resources will be dedicated to what they were supposed to do and only what they were supposed to do. The batch solution is to be mentioned because in case you know that your API is going to send a lot of events, batch could be a better solution. Facebook, for example, is using batch. They are sending events every 5 seconds or when every 5 minutes, or when at least 1,000 messages unsent in the queue. So it's another solution to keep in mind. And then you got to provide an interface, which is not something we are really fond of when we are developers. Usually, we are not really good, at providing nice and shiny user interface. So I took as example the GitHub one, which is a really nice one. You can create a webhook for every repository or every organization you have on GitHub. Simply by going on the settings panel and then in the webhooks menu, and you have a first payload form that you can fill with your callback URL, and then you're going to choose which events you would like to retrieve. By default, it's just the push event. You can decide to be notified for every event that occurred, or you can simply select them. And then you're going to receive this kind of things. So I really appreciate this one because it's you got this really lovely GitHub event header in the request, which tells you precisely what has happened, if it's an issue, if it's a pull request, if it's a merge, etc. And then in the payload, you got all the details about the event. You know exactly what has happened. So now talking about pros and cons of webhooks. First of all, when webhooks appears, people were like, whoa, we got a real-time update for real. Yeah, not really for real. It's, I would say, almost real-time updates because it will depend a lot on the implementation of the queue the API provider has made. So, for example, if it's a batch and there is a 5-minute delay, it's not real-time. In financial domains, it makes a big difference to have 5 minutes update. Without dedicated resources, because if we are talking about the solution which is not a solution and that we could not mention anymore, should not mention anymore, so polling, you will need to have dedicated resources to make those polling requests. With webhooks, you don't need that anymore. It's easily consumed because it's a post request, and we already all know about how to consume a post request. And easily integrated because you just need a web server, and you probably already got a web server. Now, looking at cons, it provides a poor user experience most of the time. Obviously, I took as example GitHub, which is one of the best user experience you can expect, but it's not the case for every API provider. It's a nightmare to debug. To make things clear, some companies have made their business about debugging webhooks. Okay? It's asynchronous, so it's quite tricky. It does not work with all clients because your smartphone, for example, is not a web server. So webhook, a post request is not really the kind of thing he expects to receive. And last but not least, you can only do manual setup. It means that you can programmatically create webhooks. There is some known issues that it's important to be aware of. For both consumer and API provider, the most important issue is the DDoS attack, because every part is going to expose a resource publicly. So for example, as a consumer, if your resource is cached by some malicious user, you can receive much more notifications that you expect to. You can be, someone can subscribe you to events you haven't asked for, or just even if the API provider is going to send much more requests than your web server is able to handle. You will end up with a DDoS attack the same way. For the consumer, the other problem is missed notification, because the API provider is not supposed to check that you have properly received the notification. So if for any reason your web server is down, it will be just missed. And in the other case, if the API provider is taking care of the answer you send back, and if for some reasons your web server does not respond with the expected code, but you still have the notification, you received it and saved it, then you will have the deduplication issue. So, quick checklist before implementing webhooks. First of all, one callback per webhook. It will be First, it will make your life easier if you need to debug. If possible, make it as less human readable as possible. Okay? Don't follow your traditional API scheme. There is no need. It's going to be read by just a computer. Make it unguessable. Check if there is some expected answer. Be sure that you can handle the request number. Monitor the payload side. This one can sound a little bit odd, but GitHub, for example, is capping their payload at 5 meg. So if the event they're supposed to send you is more than 5 meg, well, it's just not going to be sent. And handle duplicates. And on the API provider side, well, the only real thing you get to do is to implement authentication. It's not in the spec because there is no spec, but it will make the world better for everyone. So now talking about WebSub. So WebSub, which you probably know under those names, because it was formerly known as PubSub HubHub and PubSub and Push, and then someone realized, that PubSub HubHub was not very catchy name. So marketing guys are in the game now. Woo. It's an open protocol. It's now the W3C. It's a proposed recommendation, of the W3C since April 2017. That's the moment where they decided to change the name. It's based on the publish-subscribe pattern, so you will find a lot of common things with webhooks, and on topics. Well, topics is simply a resource, basically, but it's a term that is coming frequently when you're reading about PubSub, so it's good to know it. And it was originally designed to deal with RSS and atom fields, but now we can use it for almost everything. And you have these two very useful resources on GitHub. The first one provides a lot of examples in different languages, and the second one is the W3C recommendation. So, WebSub. WebSub basically is an ecosystem of publishers, hub, and subscribers. Probably the most known as publishers is Medium, whereas WordPress is an important one. As a hub, you've probably heard about Superfeeder, which has been acquired by Medium last year, actually. But Google App Engine provide a very nice hub for free. And famous subscribers would be, for example, Feedly, that you probably use if you were using Google Reader a long time ago, and Flipboard. So how does it work? Well, first of all, when we want to subscribe, the publisher has to first go through the discovery step. So he's going to provide two links, whereas it's in his header or on the main page, but it's going two links that indicates two things. The first one is the hub that the publisher is going to send notifications to, and the second one is called self. It's basically itself. When we get these links, as a subscriber, we can send a subscription request to the hub. So we're going to make a post request and say, OK, I'm in mode subscribe. That's the topic I'm interested in, the resource I'm interested in. And that's my callback URL. Reminds you something, I think. And here, a very important step. The hub is going to check that you are the person you pretend to be and that you really want to subscribe to this feed. So it's going to make a GET request on your callback URL. And it just had a little parameter in the header. It had a hub challenge. And this hub challenge, it's a random string that you, as a subscriber, has to send back to the hub on your response. And only that field. That's important. So once you've done that, it's fine. You have subscribed to events. And so here it's, I show you an example of a consumer setup for WebSub. So I have to tell you the terrible truth. Facebook is lying to you. I'm so sorry. I know it's a shock. So Facebook, actually, they exposes WebHooks, but it's the best implementation of WebSub I found. OK? Technically, looking at spec, it's WebSub. So first of all, when you want to create a subscription, you can choose if you are interested by user or page or applications or whatever. So this is our topic. And then you're going to select which kind of events you're interested in. So once you've done this, you have subscribed to the hub. The publishers is going to ping the hub each time he has new content to send. So it's going to make a post request to the hub and said, OK, I'm in mode publish, and this is the URL of my updated resources. And here comes the tricky part. So the hub is going to proceed to the content distribution. It's going to make a post request on your callback URL, giving you those two links that you've already saved before, the hub and the self. But the self now is pointing to the updated resource links. And as a subscriber, well, you're going to have to pull the updated resources. You're going to have to make a GET request to the updated resources to retrieve the content, because actually what a WebSub is sending to you is this. So you know which fields have changed. You know that something new has been published. Sometimes you can have a little preview if it's a blog post, for example, but you will not have the entire content. So that as a provider, as I'm not sure that you're interested by the content, instead of sending it to everyone on Earth, I'm going to just send the update, and you, if you're interested, are going to pull it, and I'm going to save resources this way. And then, and that's the last step, which is clearly mentioned on the specification of WebSub, and that's interesting because it's not in WebHooks. You get an unsubscribe step, which is completely identical to the subscribe step. So you're going to send the same post request as the beginning, but this time you're going to say that your hub mode is unsubscribe. And the hub is going to check, once again, that nobody is trying to unsubscribe on your behalf by sending you a hub challenge that you are going to send on the answer as an answer of the GET request. So looking at pros and cons of WebHooks, well, we fixed the poor user experience. We fixed the manual setup because we got API. We can do it dynamically. But now we got to make another call to get data. So it's not really that fine. Looking at known issues, obviously we fixed the DDoS attack. I mean, unless you're still able to manage the number of requests received by the API provider. But we still have the problem with missed notification and deduplication. So now it's time for a little demo. And I'm going to need your help. So this is a repository of mine. I'm going to zoom a little bit. And I would like you to ask to go on this web page if you've got a GitHub account. So it's called WebHooks demo. It's the code of the demo I'm going to do today. And so I would like to create a WebHooks on this repository, and so that we can see how it works, how simple it is to create a webhook. So I got this very simple application. I'm going to zoom a little bit. OK, I hope it's readable. So it's just a JavaScript application with an Express server, which at the moment does not know how to do a lot of things except responding hello Nordic APIs to a GET response. That's fine, but not enough. So we are going to add a post method, which is going to deal with the slash webhook resources, and we're going to have a request and a resources as parameters. Okay. So first of all, we're going to retrieve the kind of event we have received. So we are going to look at the request, look at its header, and search for the header we've seen previously, the X GitHub event. Once we get this, we're going to switch on the event type. So in case it's a ping event, so a ping is the first event GitHub is going to send to you to test that the webhook is perfectly configured. First of all, we're going to answer to our API provider by saying, OK, ping event received, for example. And we are going to log it so that we can check that everything is going fine. OK, break. And now, in case it's a watch, which is the event we are going to be interested in today, we are going to send, again, a response to our API provider saying, OK, watch event received. But we would like to log a little bit more of information. So we are going to say new watcher. And we are going to retrieve it in the request. So we are going to look at the payload, look at the sender, and look at the login. OK, break. And we are just going to add a default, just in case, might be useful, with 400 status and a send, which is going to say unsupported event received, for example. OK, now, we're going to log it. OK. So at the moment, pretty simple. We're going to start our application. So by just running node app.js. OK. I'm just checking that it's actually started by calling localhost. OK, so it says, hello, Nordic APIs. Everything is working fine. If you remember properly, we've said before that you can't expose the localhost resource to webhooks. So I'm going to use ngrok to expose it. So I just using ngrok, which provides me a URL I can expose to the outside world. And now I'm going back to the GitHub pages. So I'm going into settings and the webhooks menu, and I'm going to add a webhook. So I paste here my the API provided, the URL provided by ngrok, and I'm going to add the /webhook resources that I've declared there. I'm going to opt for the JSON content type, and I'm going to select the watch event. So now it's the moment of truth. We're going to add the webhook, and it's going to send the ping event. And it looks like it has worked. So if we are going back there, we got a 200, and we have received a ping event. I don't know if it's and we got a new watcher. Thank you. So you can go ahead and simply star it there. And here we have new watchers. Here it is. Quite simple, isn't it? So as a conclusion, I would say that if you have to opt for one technology or the other, I would recommend webhooks for everything which is for every event which is the beginning of a workflow. So for example, GitHub is a perfect example. Each time I got a new issue, I would like to email developers, or each time I got a new pull request merged, I would like to trigger a Jenkins job. But it's also a good client for IoT, because you never know when your IoT sensor will detect something, but you know that you would like to react immediately. WebSub, at the opposite, I would really keep it for events where the data is not going to be consumed anytime. So typically, videos on YouTube, Facebook posts, blog posts on WordPress, and all that kind of things, so that you can save resources. That's it. Thank you very much for your attention. I think we got 2 minutes left for questions.
Questions with the couple minutes that we have? Webhooks? Questions?
So the WebSub is that I often see as called a thin push compared to a thick push where there is all the data. Is there any standardization on the area of having a thick push, so not only the event but the data as well?
So it's an option of hubs, basically. The hub I've mentioned earlier, which I can't remember the name now, they provide fat pings, but it's a paying option. You know, you get to make money at some point. So
More questions? Maybe one more? Yep.
How about streaming events via WebSockets?
sorry,
About streaming events via WebSocket. So the customer just opens the socket and you stream the events.
So WebSocket, to quickly answer, WebSockets are bidirectional. And they are binary, so they support both text and binary. It's not HTTP, it has its own protocol, which is a TCP-based protocol. So it means that you will have a lot of configuration to do on both sides to use WebSockets. So most of the time, WebSockets are really not necessary. It's over-engineering most of the time because WebSockets are great when you're doing chats or video games. And you really need to have an interaction with more than text only on both sides in real time. But it's really the only use case I can find for WebSocket. Any other question?
YOLO. I had to look that up. What is YOLO?
You only live once.
Oh. So dress up as Darth Vader and ride around on a Ferris wheel.
You only live once.
Excellent. All right, how about another round of applause for Audrey?
Thank you very much.
And also, small token of our appreciation.
Thank you.
Thank you.